This video is about how to solve quadratic equations. Let's begin by saying exactly what a quadratic equation is. It's an equation that must contain a term that has got x squared in it. So we can have 3x squared minus 5x squared, or perhaps just x squared on its own. The equation can also have terms in x, so it might have a term 5x, or perhaps minus 7x, or perhaps 0.5x. It can also have constant terms, just numbers, so perhaps 6, minus 7, a half, etc. It can't have any other terms in it. It can't have any higher powers of x in it, so it can't have x cubed in it. It can't have things like 1 over x in it. So, what does our most general quadratic look like? Ax squared. It must have this x squared term in it. And a is just a constant. It can be 1, as it is here, 1x squared. It could be 3. It could be minus 5. It could be any real number. Plus bx. Now this term may not be there. B could be 0. Plus c. C is the constant term. And again, that term doesn't have to be there. C could be 0. And then we say equals 0. So that's our most general quadratic. And what we're going to have a look at is how to solve all the different varieties of this kind of equation that you can meet. There are 4 basic ways. First way is by factorizing. I'm going to assume that you know how to factorize, but there is another section of the video that is to do with factorizing quadratic expressions. So if you're not sure how to factorize, perhaps it would be a good idea to look at that. Second method is by completing the square. Now again, I'm going to assume that you know how to complete the square. But again, there is another video that relates to completing the square. So if you're not sure how to do that, perhaps you might look at that video first. Then we're going to have a look at how you use the formula. There's a special formula for solving quadratic equations. We're going to be using that. And finally, how to solve a quadratic equation using graphs. Of these 4 methods, 2 of them are by far the most common. And whilst one doesn't want to say you mustn't understand everything, you can pick a part of what you do, you really do need to concentrate on factorizing and the formula. Those are the 2 most important ones. So, let's begin by having a look at how to factorize and solve a quadratic equation. I'll begin with 3x squared equals 27. There is no x term, but that still doesn't stop it being a quadratic equation because it's got this x squared term in. So we begin by writing it equals 0. So I take the 27 off each side. So we have 3x squared minus 27 equals 0. That's the first step, and one that you must do every time. Next, look for a common factor. Is there a common factor in the terms on the left-hand side of this equation? And if there is, let's take that common factor out. And here we've 3x squared and also 27, which has a factor of 3 in it. 27 is 3 times by 9, so we can take out the common factor of 3. And that will leave us with x squared minus 9 equals 0. Inside this bracket now, we have the difference of two squares. We have x squared, take away 9, which is 3 squared. And this is a standard piece of factorising. So that's 3 brackets x minus 3, x plus 3 equals 0. Now, when we multiply two expressions together, and we're not quite sure of their value, but we do know what they give us, in this case 0, we can make certain deductions about them. So if I have one number multiplied by another number and the answer is 0, then one of these numbers, that one, or both of them are 0. So we have x minus 3 equals 0, or x plus 3 equals 0. So we end up with x equals 3, or x equals minus 3. Notice two answers. And that will be a theme that I will return to again. Let's just recap there what we did. First of all, we put everything equal to 0. Then we extracted, took out any common factors. Why should you do that? Well, let's just run through this one again. 3x squared equals 27. And let me break a few of the rules that I've just said. So let me cancel both sides by 3, since obviously 3 goes into 3x squared and leaves us x squared, and 3 goes into 27 and leaves us with 9. So I've got x squared equals 9. Now let me do the natural thing, which is to take the square root of both sides. Square root of x squared is x, and the square root of 9 is 3. I've only got one answer. And if we look back, two answers. I've lost one. By factorising, I was able to get two factors, and that gave me two answers. In doing this step from here to here and taking the square root, what I have forgotten is that as well as 3 squared being equal to 9, minus 3 squared is also equal to 9. So at this point, I should have said, or x equals minus 3. Now, it's very easy to make this kind of mistake and lose one of the answers. So the best way to tackle these is the way that I've just set out. Write them as equals 0, take out common factors, and then look at a factorisation leading to giving you two answers. Let's take another example. This one will take us 5x squared plus 3x equals 0. It's already written as equals 0, so we don't have to worry about that first step. So the second step is to look for a common factor. I've got 5x squared plus 3x. So I've got a common factor here of x. So I can take that out, leaving me with 5x plus 3 equals 0. And here again I've got two numbers, x and 5x plus 3. I'm not sure what they are, but what I do know is that in multiplying them together I've got 0. This means one of them must be 0, or the other one must be 0, or they're both 0. So I can write down x equals 0, or 5x plus 3 is also equal to 0. So there's one answer, x equals 0. And now this is just a simple linear equation. Linear, remember, because it's just got an x in it. No x squareds, no x cubes, no 1 over x's, just an x. And this solves quite easily. 5x equals minus 3, taking 3 away from both sides, and then dividing both sides by 5, minus 3 over 5. So there are my two solutions, x equals 0 and x equals minus 3 over 5. What I'd like to do is just perhaps run through this one again and show you where the mistakes can come when tackling equations like this. Because what's special about this one is there's no constant term. An x squared term, an x term, but no constant term. So what might be the mistake that we would make when doing this? Well, the mistake that we might very well make is to say, oh yes, a common factor of x, one there in the x squared term and one there. So I'll cancel by that x. 5x plus 3 equals 0, dividing each term by x. And then 5x is equal to minus 3, and then x is equal to minus 3 over 5. One answer. X equals minus 3/5. If we go back, we've x equals 0 and x equals minus 3/5. We've lost this answer here. We've lost x equals 0. Why? Because we didn't look for a common factor at this point. We went straight on to simply divide throughout by the x instead of taking it out as a common factor. So you must be aware of that. With quadratic expressions, we're looking for two answers, two solutions, two roots. Those are, if you like, the different words that we use. Answers, solutions, roots. They all mean the same thing. Okay, we've looked at two particular cases. One where we did not have an x term, and another one where we didn't have a constant term. So now, let's have a look at one that's got both of those in. So if x squared minus 5x plus 6 equals 0. And we're going to solve this by factorising. So, to factorise a quadratic, we need to search for two numbers that when we multiply them together will give us this number here, 6, and when we add them together will give us this number here, minus 5. So we look at that, and 3 times 2 would give us 6, and minus 3 and minus 2 added together would give us minus 5. But minus 3 times minus 2 is also 6, so those look like good choices. Minus 3 times by minus 2 gives us 6, and minus 3 plus minus 2 gives us minus 5. So, we take this expression again, x squared. Instead of minus 5x, we write this as minus 3x minus 2x plus 6 equals 0. Now we look at these two terms and we take out the common factor. And in this case, that's x. And that leaves us with x times x minus 3. And now we look at these two terms and we take out again a common factor. Well, obviously there's 2, but this is minus 2x. So because this is minus 2x, I'm going to take minus 2 as the factor. Minus 2 brackets x. And now I need to put something in here so that I have minus 2 times gives me plus 6. And that must be minus 3 equals 0. Now I've got one lump of algebra there and one lump of algebra there, and they share this common factor, x minus 3. X minus 3. So we take that out as a common factor, and we're left with the other factor as x minus 2. X minus 2, close the bracket, equals 0. And so here I've arrived at two numbers multiply it together, and they give me 0. So one of them must be 0, or the other one must be 0, or they perhaps both 0. So if we just write that down again, x minus 3 times by x minus 2 equals 0, then either x minus 3 equals 0 or x minus 2 equals 0. This tells us that x must be equal to 3, or this one tells us that x must be equal to 2. And so again, we've arrived at 2 possible answers. Let's take another one. This time, let's take something that does not have a unit coefficient in front of the x squared. So we'll take 2x squared plus 3x minus 2 equals 0. Now, in order to solve this one, we're looking for two numbers that will multiply together to give us 2 times by minus 2. So two numbers that multiply together to give us minus 4. We're looking for those same two numbers to add together to give us 3. Well, 4 times by 1 would give us 4. And if we made the 1 a minus 1, 4 times by minus 1, that would make minus 4. And 4 plus minus 1 would give us 3. So these are our two numbers that we need. So again, 2x squared, and then the x term we can rewrite as 4x minus x minus 2 equals 0. And we look at these two terms for a common factor, and there's a 2 here, and 4 is 2 times 2, and there's an x and an x in the x squared and an x with the 4x. So our common factor there is 2x, leaving us with x plus 2. And now we want a common factor here, and that will be minus 1 times x plus 2 equals 0. Again, we've two lumps of algebra here, and in each one there's a factor of x plus 2. So that's our common factor that we can take out, x plus 2 times by 2x minus 1. So again, we've arrived at two brackets multiplied together, x plus 2 times by 2x minus 1. So one of these has got to be 0, or possibly both of them. Let's write that down again. X plus 2 times 2x minus 1 equals 0. So either x plus 2 is 0, or 2x minus 1 is 0. This tells us that x is minus 2 by taking 2 away from both sides. And this tells us that 2x is equal to 1 by adding 1 to each side. And now we divide both sides by 2, so we have x equals a half. So we've ended up with our two answers for this quadratic equation. Let's take another one. 4x squared plus 9 equals 12x. It doesn't say equals 0. So let's write it so it says equals 0. 4x squared minus 12x plus 9 equals 0. Check common factor. Something we didn't do in the last question, but then there wasn't one. But these numbers are a bit bigger, and there may just be a common factor there. But as we look, there is no common factor. Factorize it. We're looking for two numbers that would multiply together to give us 36, 4 times by 9, and would add together to give us minus 12. Well, 6 and 6 give us 36, and if we make them both negative, minus 6 times by minus 6, they still give us plus 36, but now they add together to give us minus 12. So we've got 4x squared minus 6x minus 6x plus 9 equals 0. In these two terms we want the common factor, and that will be 2x, because this is 4 and 6 and x squared and x. So we'll take the 2x out, giving us 2x minus 3. And then here again, common factor, 6x and 9. There's a common factor there of 3, but this is a minus sign here. So we want minus 3 times by 2x. That gives us the minus 6x, and minus 3 times by something has to give us plus 9. So that will be minus 3 again, equals 0. Two lumps of algebra, a common factor in each one of 2x minus 3, leaving us with 2x minus 3 times 2x, and 2x minus 3 times minus 3. One of these two, or both of them, can be 0. So we have 2x minus 3 times 2x minus 3 equals 0. And so 2x minus 3 equals 0, or 2x minus 3 equals 0. Adding 3 to both sides, 2x is equal to 3, and so x is equal to 3 over 2. Of course, this is exactly the same, so we can write down the same stuff, 2x equals 3, and x equals 3 over 2. Two answers again, the same answer twice. And because I can say it like that, it enables me to keep up this idea that quadratics are going to lead me to two answers. An answer may be repeated, but I still get two answers. Let's take one more example. X squared minus 3x minus 2 equals 0. We're looking for two numbers that will multiply together to give us minus 2, and will add together to give us minus 3. They've got to multiply together to give us minus 2. Well, that would suggest 1 and minus 2. But no matter how we try and add 1 and minus 2 together, we're not going to get minus 3. And if we said, well, let's try minus 1 and 2, then again, they're not going to add together to give us minus 3. In short, this question does not factorize. And because it doesn't factorize, we're going to have to look for another way of solving it. So, how are we going to solve an equation that does not factorize? Well, one option is completing the square. I want to have a look at this not because it's the regular way in which we would try to solve an equation that doesn't factorize, but because in doing it, we'll see how the next method, which is using the formula, actually works. So, let's have a look at what we've got. X squared minus 3x minus 2 equals 0. Now, in order to complete the square, we look at these two terms. Now, this is an x squared, and this is minus 3x. So if I want to get a complete square, which remember is like that, then I've got to have an x in there, and I've got to have a constant term here, so that when I do the squaring, I'll end up with minus 3x. and we know how to do that. You take a half of the number that multiplies the x. So that's minus 3 over 2. So that when we multiply out that bracket, we'll get x squared, we'll get minus 3x, but we'll also have an extra term. We will have the square of minus 3 over 2 extra. In other words, we'll have added on minus 3 over 2 squared. So if we've added it on, we better take it off in order to make sure that we've got exactly the same value, the same expression. And then, of course, I've got minus 2 here. So let's put that in. So now this expression is exactly the same as that one. So let's keep this bit at the front. X minus 3 over 2 all squared. And now what's this? Let's simplify this here. Well, minus 3 over 2 squared is 9 over 4. Take away 2 equals 0. So we've got x minus 3 over 2 all squared minus, now let's write this all over 4. 2 over 4 is 8 quarters, so I'm taking away 9 quarters, and I'm taking away 8 quarters, so I'm taking away 17 quarters altogether. Now this now looks more manageable. Let me just turn over the page and write this down again. X minus 3 over 2 all squared minus 17 over 4 equals 0. Now we're going to add the 17 over 4 to both sides. So we'll have x minus 3 over 2 all squared is equal to 17 over 4. And now I'm going to take the square root of both sides, remembering that I must get plus or minus at this side. So the square root of this will be x minus 3 over 2 equals. To take the square root of this, I need the square root of the top, which is going to be plus root 17 over 2, or minus root 17 over 2. Over the 2, because that's the square root of the 4. Now I add this bit to both sides, the 3 over 2, so we have x equals 3 over 2 plus root 17 over 2, or x equals 2 minus the square root of 17 over 2. And just for the sake of completeness, I'm going to put all of this over this 2. So 3 plus root 17 over 2, or 3 minus root 17 over 2. So there we've done a question that involves completing the square. Again, we've got 2 answers, but there are 2 further things to notice here. I've left these square roots in. You would normally take a calculator and work out an approximate value of these 2 answers to a given degree of accuracy. That might be to 2 decimal places, it might be to 3 significant figures. But these are exact answers. The minute you put decimals in, those answers are not exact. They are approximations to a given degree of accuracy. The third thing I want you to notice is their form. 3 plus a square root, 3 minus a square root, and over something. Because when we look at the next method, you're going to see that form again. So, how else might we tackle this equation? Let's remember what it was. Initially, it was this one. X squared minus 3x minus 2 equals 0. We saw that it didn't factorize. So we did it by this method of completing the square. So what we're going to do now is look at the formula. And to do this, I'm going to take it generally to begin with. So here is our general quadratic equation. Ax squared plus bx plus c is 0. And there is a formula which will solve this equation for us. And it's x equals minus b plus or minus, and it's the plus or minus that's going to give us the two answers, the square root of b squared minus 4ac all over, a whole lot over 2a. And that's the formula for solving quadratic equations. And unfortunately, you do have to learn it. But if you say it to yourself each time you write it down, x is minus b plus or minus the square root of b squared minus 4ac all over 2a, helps to remember it. Makes it sound stupid, but it helps to remember it. So, let's take this formula and use it to solve the previous equation that we just had. So the equation that we had was x squared minus 3x minus 2 equals 0. Let's begin by identifying a, b and c. There's 1x squared, so a must be equal to 1. B is the coefficient of x, and that's minus 3, so b equals minus 3. C is the constant term, and so here c is equal to minus 2. Let's write down the formula. X equals minus b plus or minus the square root of b squared minus 4ac all over 2a. By writing it down each time, it's a way of helping to remember it. Now let's substitute these values in. So b is minus 3, so that's minus 3 plus or minus the square root of b squared minus 3 all squared minus 4 times a, which is 1, times c, which is minus 2. We'll just extend that square root sign. All over, everything over 2a, which is 2 times by 1. And now let's tidy this up. So we have minus 3, that's plus 3, plus or minus the square root of minus 3 all squared is 9. 4 times by 1 is 4, times by minus 2 is minus 8, and we've got this minus sign here, which makes plus 8, all over 2. And what we see we've got is 3 plus or minus the square root of 17 all over 2, which are the answers that we had before. Again, we can work out each of these answers, 3 plus root 17 over 2 or 3 minus root 17 over 2, using a calculator. But again, remember, any answers you get doing it that way are approximate. These answers are exact. Let's take one more example of using the formula. And the one that we'll take this time, 3x squared equals 5x minus 1. It doesn't say equals 0, so we must write it as equals 0, because that's the form that the formula demands we have the equation written in. So 3x squared, and we've got to take 5x away from each side, and we've got to add 1 to each side. That ensures that we have that. Now let's identify a, b and c. A is the coefficient of x squared, which in this case is 3. B is the coefficient of x, which in this case is minus 5. and c is the constant term, which in this case is 1. Again, let's write down the equation. X is minus b plus or minus the square root of b squared minus 4ac all over 2a. And make the substitution. B is minus 5. We want minus b, so this is minus 5 plus or minus the square root of b squared, so that's minus 5 all squared, minus 4 times a, which is 3, times c, which is 1. And that's all over 2a, 2 times a, which is 3. Now, we'll simplify this. Minus 5 is plus 5, plus or minus the square root of. Now, minus 5 all squared is 25. 4 times 3 times 1 is 12, and the minus sign is minus 12, all over 6. And so we just squeeze that one into this space here. We 5 plus or minus the square root of 25 minus 12, which is 13, all over 6. And again, there are two exact answers there. 5 plus root 13 over 6, and 5 minus root 13 over 6. We can work out their value, approximate value that is, by using a calculator and finding out what it tells us about root 13. But those are two exact answers if left in that form. Now, basically, if a quadratic factorizes, then you should solve it by using factorization, because it's clearly much quicker than this. Don't use completing the square unless you're specifically asked to, and use this method by using the formula, solving by using the formula for those that do not factorize. However, right at the very beginning, we did say there was a fourth method. And so I just want to look quickly at what this fourth method is. We said this fourth method was by graphing. Okay, let's have a look at what we know about quadratic functions. If x squared is positive in our quadratic function, then we're going to get a U-shaped curve like that. If, on the other hand, x squared is negative, then we're going to get a hill like that. Now, set on a graph, then we might have a graph that looks with a positive x squared, say something like that, or we might have a graph that, say, looked like that, or we might have a graph that looked like that. Now, this is the line equals 0. The value of the function equals 0. And so here we can see our two values of x. Here we can see one value of x, which makes the function equal to 0. And we've said we call that a repeated root, or a double root. But here, the graph does not reach the x-axis. It does not reach a value equal to 0. And that means we actually have no roots. So there are some quadratic equations that you cannot actually solve. Well, mathematicians make it happen, so to speak. They make them solvable by inventing a new kind of number. But we're not going to deal with that at the moment. As far as we're concerned, we either get two roots, a repeated root, or for the moment, no roots at all. But you will see that we can make an equation like this have two roots in a very special way. Clearly, what we've done for a positive x squared term, we can do for a negative x squared term. Because again, we can have a graph, say, that looks like that and does not reach the x-axis. or we can have one that, say, looks like that and just touches the x-axis, or we can have another one that looks like that. And again, two values there and there, a repeated value of x there, and no values of x there. So bearing that in mind, let's have a look at our trial equation, if you like, the one that we've used to start off each of the last two sections. X squared minus 3x minus 2 equals 0. And let's think how we can solve this by using a graph. Well, let's just look at this bit, the x squared minus 3x minus 2, and think of it as a function, not as an equation equals 0, but just a function. Now, one of the things is that if we put in, say, a value of x equals what? Let's say something like 1. Then we've got 1 minus 3 minus 2. It's clearly negative. If I put in a value, let's say something like 4, then I get 16 minus 12 minus 2. Well, that's positive, isn't it? Because it's an overall value of 2. If I put in a value of, say, something like, let's say, minus 2, then I get 4 minus 3 times by minus 2 is 6, so I get 10, take away 2, 8. It's positive. So as I've gone from one value of x, I've got a positive value, then a negative, then a positive value of x. So clearly it's going to cross the x-axis at some point. So what I have to do is choose a value of x, or a range of values of x, that will enable me to graph that different behaviour. First of all, positive values, then negative values, then positive values again. So, the range of values that I'm going to take them going from minus 2 in unit steps. I'm going to go up to 5. I'm going to calculate each term in turn. So let's just rule those off out of the way. X squared, that will be 4, 1, 0, 1, 4, 9, 16, and 25. The next term is minus 3x. So I have minus 3 times by the value of x. So minus 3 times by minus 2 is 6. Minus 3 times by minus 1 is 3. Minus 3 times by 0 is 0. Minus 3 times by 1 is minus 3. And so on. Minus 6, minus 9, minus 12, minus 15. Now we come to the last term, minus 2. And that stays the same because it's the constant term no matter what the value of x is. So we can just write in a line of minus 2's across our table. And now we can work out x squared minus 3x minus 2. Because it's going to be the sum of each of these columns. So we have 6 and 4 is 10, take away 2 is 8. 1 and 3 is 4, take away 2 is 2. 0 and 0 and minus 2 is minus 2. Minus 3 and minus 2 is minus 5, and 1, minus 4. Minus 6 and minus 2, add 4, that's minus 8, and 4 gives us minus 4. 9 and minus 9 is 0, and minus 2 gives us minus 2. Minus 12 and minus 2 is minus 14, and 16 gives us plus 2. Minus 15 and minus 2 is minus 17. Add on the 25, and that gives us 8. And notice what we've got is symmetric across the table. Now, that just happened to be because I picked values that were going to give me a complete symmetry, but you'll always find a degree of symmetry in the table. Now what I would need to do now is make a graph. Now I don't have any graph paper, and so effectively what I'm going to do is I'm going to draw a quick sketch, because we know what the answers to this equation are, but I just want to show you how you would go about doing this. So let's do that. We've got our x-axis, our y-axis. We've got values -2, -1, 1, 2, 3, 4, and 5. And I'll mark these off in even numbers: 2, 4, 6, 8, and -2 and -4. So let's just flick back for a couple of values here. -2 is 8 and -1 is 2. So I've got a point roughly there and a point roughly there. Then when it was 0, I had 1 here at -2. There we go. And then at 1 and at 2, they were both -4, so they were there and there. And then at 3 and 4, they were -2 and 2, so they were there and there. And then at 5, it was back up here at 8 again. And so I can get a nice, smooth curve through these points. And then back up to there. And where are my answers? Well, they're here. That one and that one. Those are the values of x for which x squared minus 3x minus 2 equals 0. Supposing, however, I hadn't been given that equation, but I've been given x squared minus 3x minus 2 equals 6. Now this shows the advantage of graphs. I took a long time to work this out and to draw this. And had I drawn it neatly, well, it would have taken even longer. But because I have drawn it, I can use all the data I've got, not only to solve the first equation, but to solve this equation as well. Because all I'm looking for are values of x which make the function bit equal to 6. So where is the function bit equal to 6? Well, we go across here, and we can see these are the points on the curve where it's equal to 6. And so if I come down, these are the values of x which correspond. And I can just read off those values of x. So by drawing the graph, I've not only been able to solve that one, but I've been able to solve this one as well. What about if I have x squared minus 3x minus 5 equals 0? Can I use this graph again? Well, it's got the front bit the same. It's this bit that seems to be different. So if it's different, well, let's make it the same. So let's make it x squared minus 3x minus 2. And then what do I need to keep it as minus 5? Well, I need minus 3 equals 0. So now this is my function bit the same. So I'm actually looking for when my function bit is equal to 3. And again, that's within the possibilities. Here we have the value 3. We can go across and there, and then we can come down and read off the values of x which give us that. So for all drawing a graph took a long time, it actually enabled us to solve more than just the equation for which we drew it. So let's just recap. There's a basic quadratic equation. Ax squared plus bx plus c equals 0. There are 4 ways of solving it. First, by factorising, and you should try that way first. Second, by completing the square, but that's not advised, so to speak. Third, if it won't factorise, use the formula. And those two ways, factorising and using the formula, are the prime ways, the first methods of recourse that you should use. Finally, there's drawing a graph. Time-consuming, but may be beneficial if you've got a lot of the same kind of equation that you need to solve.